Good morning, everyone. I want to welcome you to my lecture today. Today, we basically are going to continue with the chapter 8 that we started the other time. We call that additional topics in analysis of variance. Of course, we started on Monday, and this is going to be part 2. Of course, I promised there was going to be a 4-lecture series on this particular chapter. Okay, so in the outline today, I'm basically going to discuss what we call contrast in one-way and two-way analysis of variance. Of course, I'm going to show you the difference between contrast and pairwise comparison that we've done before. Okay, then I'm basically going to demonstrate how this can be achieved or how this can be implemented or using our software. Then I'm also going to walk you through an example of contrast in ANOVA with covariate. Okay, so let's get started. Now, the very first thing I want to do today, I basically want to first tell you, well, what is it different? What do we mean by contrast and how is it different from pairwise comparison? Now, let me give you this pair, this right now. This is what happened when we are trying to compare means in more than 2 groups, okay? And at the end of the day, if the null hypothesis is rejected, you conduct either one-way or two-way or three-way or factorial design and so on like that, and you rejected the null hypothesis. Of course, you know, one of the weakness of analysis of variance is that the analysis of variance will now tell us where the difference lies. The analysis of variance is just basically going to tell us, okay, there's a statistical significant difference. If we want to know where the difference lies, we normally consider what we call post-hoc test. Okay, the post-hoc test is what we call multiple comparison test, where you basically are going to have opportunity to compare the levels of the treatment on head-to-head basis. Okay, and let me tell you this, it is called post. If you look at the word post, it means you're basically going to do that after you've conducted an experiment, you've already seen the result, and you've rejected the non-hypothesis, and you basically want to investigate where the difference lies. Okay, so that is, and of course, I give you, when I say post-hoc test, I think we discuss Fisher, LSD. We discuss, Bonferroni. Okay, we discussed Bonferroni, and we also talk about Turkey. Okay, of course, I think the other time when we met, I actually, walk you through, the appropriate situation where this can be applied. Well, let me tell you this. How is post-hoc test, okay, different from the contrast that we want to talk about now? Let me tell you this. When we talk about contrast, even before we go into the experiment, even before we conduct analysis of variance tests, or maybe we have prior knowledge, okay? We have a prior knowledge, okay? We have the prior knowledge of of the hypothesis that we basically want to test. Okay, maybe before we go into the experiment, we basically want to conduct a statistical hypothesis between certain treatment combination, even before we conduct analysis of variance at all. And that is the reason why we normally refer to contrast as a planned comparison. We call contrast, okay, planned comparison. Okay, it is not a post hoc. Okay, it is actually, we have certain things in mind that we basically want to compare even before we go into the analysis. Okay, so that is a difference between them. Okay, but let me tell you this. Another difference between contrast and the post-hoc test is that with the post-hoc test, whether you are using the Fisher LSD or you're using the plan, you're using the Turkey or you're using the Bemferroni, okay? I want to tell you that you are actually comparing the levels of treatment, you're comparing them on head-to-head basis. But with a contrast, do you know that you can actually compare one level of the treatment with more than one level? You can compare one level with two levels, even one level with three levels, two levels with three levels, and you are not able to do that with a multiple comparison, because the multiple comparison will only allow a comparison to be made on head-to-head. Okay, that was why we called the multiple comparison. We basically call that pairwise. Pairwise. But let me also tell you this. We can also do pairwise with contrast as well. I'm going to say this again. We can also do pairwise with contrast as well. Now, I want to walk you through an example right now. How do we construct contrast? I basically want to start an example from one-way analysis of variance. Now, one-way analysis of variance, I actually looking at the effects of two drugs, okay, relieving. I want to look at the effect on reducing hypertension or anxiety. You know what I'm basically want to do before I go into the research. Of course, if you have, let me just write this for you. We have treatment, okay, and you know what? We got three levels of that. Okay, we have what we call placebo, okay, and we have the other two drugs, drug one, okay, drug two, okay. Now you know what we want to do. We know that if we really want to compare these three levels of treatment, we're basically going to use one-way analysis of variance. But before we go into conducting analysis of variance, basically we want to compare the combination of this with this. Then we're going to do a contrast. Take a look at that. And that was why I said, for example, I said, suppose we have two treatments which are supposed to be equivalent. We believe the two of them, probably they are equivalent, okay? And for example, each of two drugs, okay, is supposed to work by binding to the receptor for adrenaline. And of course, the propanol is such a drug sometimes used for hypertension. So this is what I'm basically, I'm going to show you something right now that you're basically going to see. Now, what we want to do is this. If you take a look at this, number one, we may think that, it's just like we have a priori hypothesis. What do I mean by priori hypothesis? Even before we go into the experiment, we have certain things in mind that we basically want to test. Okay, and what we want to test, we got number one, we want to see whether the two drugs are equivalent. And number two, we basically want to see whether they are different from control. The control is placebo. Okay. Now, because I got how many levels of treatment right now? 1, 2, 3. Then if I want to know the number of contrasts that I'm actually going to construct, it's going to be the numbers of the levels of the treatment minus 1. How many do we have here? 1, 2, 3. Then it means I'm actually going to have two contrasts. The first contrast is going to be Is there any significant difference between the two drugs? The second contrast is going to be, is there any significant difference between the combination of the drug, of the two drugs, and nothing? Nothing is placebo, which we call the control. Okay, now this is one. Now take a look at this. Now, if you take a look at this now, this is what I'm trying to say. We have a drug A that I call drug and drug B, and we basically want to compare that with placebo. So what we basically want to do, if we want to conduct a contrast, what we want to do is comparing the effect of drug A and drug B on the control. We want to see whether there's a statistical significant difference between them. When you are doing that, you are actually, you want to test for contrast in one-way analysis of variance. Now, how are we going to go about that? We normally, how do we set up a contrast for that? I told you the number of contrasts that we're actually going to construct basically depends on how many treatments do we have? How many levels of treatment do we have? We got 3 levels of treatment right now. We got control, we got drug A and drug B, that which means the number of contrasts that we're actually going to construct will be 2. Now let's look at the first contrast. Now, when you are constructing contrast, we basically need to, to formulate the contrast weight. Contrast weight, I show you on Monday. The contrast weight, when you add it together, it must be equal to 0. Now, if you look at the first contrast right now, contrast 1, okay, why am I putting -1 on control? Why am I putting half and half on the other one? In that kind of, in contrast 1, what I want to do? I want to compare drug A and drug B with control. If we have 4, let's assume that we have control drug A. Okay, I wanted to say this now. I wanted to say this now. If I have more than 2 drugs, if I have control, okay, drug A, drug B, and drug C, okay, and I want to compare all these at a time with just this guy, okay, and I want to assign a contrast weight. Okay, this guy here is basically going to be 1/3, 1/3, 1/3, and this is going to be -1. I wanted to take note of that in such a way that when I add them together, they have to be equal to 0. Okay, and if they have 4 levels of this, it's going to be 1/4, 1/4, 1/4, 1/4, and this is going to be -1. Okay, that is how we assign the contrast weight. Okay, if you look at it in contrast 2, you can see we're only comparing to whether there's a significant difference between drug A and drug B. Then we go, since we're comparing one level with another one level, then the weight is going to be 1 and -1. The one we're not interested in right here is going to have a weight of 0. Look at that. If in the second contrast, I'm not interested in control. Therefore, the contrast weight is basically going to be 0. Now, the contrast 2 is trying to tell me now, I'm only want to see if there's a significant difference between the drug A and drug B. Now, this is 2 contrasts. And of course, this is the interpretation of that. What contrast 1 tests, whether or not the control group, differ from group which block the adrenaline receptors, and the contrast 2, if there's a significant difference between the 2 drugs. Okay, now you've seen that right now, and I'm basically going to go now. What if in a situation? I think I'm doing it because of those who are online. Okay, now how do we do contrast? How do we set up contrast in 2-way analysis of variance? I think I just showed you how to do that in 1-way analysis of variance. But how do we actually set up contrast in 2-way analysis of variance? Now take a look at this. I have 2 categorical factors. Of course, for us to use a 2-way analysis of variance, we needed to have a response variable that is continuous and 2 categorical factors. You know that, right? Now here, the one of the categorical factor is the analgesic drug that has two levels, A and B. And the other factor is gender that also have two levels, male and female. Okay, now how do we actually set up contrast here? And I'm going to show you now how that is going to be done. Now I wanted to take a look at this. If I write drug and I write A, drug A, drug A, drug B, and I write gender, of course, male and female, because you know why? And basically, the true drug A and B, will actually be used by male and female. Okay. Now, because of the fact that we have 2 by 2, 2 levels by 2 levels, which is basically going to be 4, right? 2 times 2 is going to be 4, right? What is going to be the degree of freedom for that? You're basically going to have 3 contrasts. Now I'm going to show you, I want you to pay attention now to contrast 1. Now we want to see, what is contrast 1 telling us? I want you to see half, minus half, minus half. Take a look at that. Okay, contrast 1. Give me 1 second. Contrast 1, you have half, okay, and minus half, you know what that means? It means you basically want to test if there's a significant difference between the 2 drugs. Look at that. Drug A and A, half and half, B and B, minus half, it means in contrast 1, you basically want to test if there is any significant difference between the 2 drugs. Now, can somebody tell me? I want to award an extra credit now. Okay, what do you think contrast 2? What is it testing? Contrast 2, can somebody tell me? What is it testing? Okay, go ahead. Oh my God, good job. Okay, you're going to send a message to me for extra credit. Now, contrast 2 is actually testing, if you see half, okay, positive half, another positive half is of male and male, and the negative half and half is on female. So which means you basically want to see whether there's a significant difference between male and female, okay, with regard to the drug. Because at times you could have situation where some drug could work more efficiently on male than female. You basically want to see, okay? And when you look at the third contrast here, look at the third contrast, positive half is on A, positive half is on B, another negative half on A, and negative half on B. Automatically, that is testing the effect of interaction. If you take a look at that. And that was what I put basically here. I put the definition here. Take a look at that. I said contrast 1. It's actually testing the main effect of the drug, where you're trying to see, is there any significant difference between the drugs, between the levels of the drug, and the contrast 2, actually comparing whether there's a significant difference between the level of gender, and the contrast 3 is basically, talking about the interaction time. Okay, now, I want to demonstrate to you now, because even though I know my TA is basically going to walk you through how to implement this now, but I basically want to walk you through how to, just to show you, okay, how this can be done now. Okay, now I'm going to have this example. Let's say, let me tell you this, you can be given a statement like this, and you can be asked to set up a contrast. But you know what? The contrast you're going to set up actually depends on the statement. You need to be able to understand how to interpret that. Let's take a look at this. For example, let's say we wanted to compare control to A and B. Look at that. That is contrast number 1. Comparing control to A and B. Okay. Now, and then compare A to B. That is different, right? In contrast 2, this is telling you compare A to B. In contrast 1, you're comparing control, okay? You are comparing control to A, B, and C. So which means there are 4 levels of treatment here. 4 levels of treatment, control, then A, B, C, okay? In the contrast 1, you actually want to compare control with the other 3 levels of treatment. Then the contrast 2 is trying to tell you, you basically want to compare A and B, and then A to C in contrast 3. Now, the question now is, you have been given a textual information about the contrast 1, contrast 2, and contrast 3. How do you set up that now? Based on this information that we have here, I just want to show you now. Now, in contrast 1, what did they tell us? In contrast 1, they want to compare control, right, with the other 3 levels of treatment, A, B, and C. Now, look at the weight. I'm basically going to write control A, B, C in the contrast 1. If I want to do that in R, I'm basically going to write C1 less than minus C into what? Minus 1, 1 over 3, 1 over 3, 1 over 3. Why do I say 1 over 3, 1 over 3, 1 over 3? That is basically the weight of the other levels of the treatment that I basically want to compare with the control. Now, the weight of the control here is -1. Is there anyone who is not clear with the way I set up the contrast weight for the first contrast? Is there anyone, whether in person or online? Those of you online, can you confirm again if you are hearing me clearly? Can somebody confirm?
Yes.
Oh, thank you so much. Thank you so much. Thank you for confirming that. Okay, now, is there anyone who is not clear with the way contrast 1 weight is actually set up? Is there anyone? You guys are all good, right? Okay, those of you at the back, you can hear me, right? Okay, you are okay. Thank you so much. Now, contrast 2 now say they want to compare A and B. Oh, take a look at this. You know, initially, you basically have control. Okay, this is what you have. You have control. Okay, you have A, B, C. Okay, contrast 1. Okay, when you're comparing control with this, it's going to be -1, 1 over 3, 1 over 3, 1 over 3, just like what you have here. But the second contrast is actually telling you, you know, there's an information. It said compare A to B. A to B, A and B, 1, -1. The one I'm not interested in, they're basically going to have a contrast of 0. Okay, the one I'm not interested in. And that was why you see that I have a 1, -1. And the last one, when you see the third one, the third contrast here is basically comparing A to C. And that is why you see the contrast weight for A is basically going to be 1. And the one for C is going to be -1. And the one we don't talk about, we have a contrast of 0. Does that make sense? Now, this is the way we can set up the 3 contrasts they mentioned in the statement. Is there anyone who doesn't really understand that? Now, what I'm doing now, I'm going to create a temporary matrix. Now, what am I showing you now? How to do that in R? You can copy this into your R software, console. You're basically going to see it's going to run. Now, at the end of the day, you're going to set up something like this. Okay? You're going to have that. And the moment you have that, then you needed to find the inverse of a matrix. Inverse of a matrix. And this is the code in R. And after that, then you actually run analysis of the model. You basically going to estimate the model, and this is the code. Finally, this is the result. Okay, now if you take a look at this table now, this is for contrast 1, contrast 2, contrast 3. Don't forget, in contrast 1, what are you talking about? You basically want to compare, in contrast 1, you are comparing control with the other levels of the treatment. Then you're going to look at the p-value associated with that. You're going to compare that p-value with the level of significance. If the p-value is less than 0.05 level of significance, of course, you're basically going to reject the null hypothesis. What is your null hypothesis? Your null hypothesis right here is basically, HO mu, if you call this one mu control, okay, you can say the mu control, equal to the mu A plus the mu B plus the mu c, and you know what? This is 1 over 3, 1 over 3, 1 over 3. Take a look at that. This is a null hypothesis. Okay? Against the alternative hypothesis that they are not the same. Now look at the second contrast and the third contrast. Okay, with this, you are actually the numbers of the p-values you're going to have, okay, depending on the number of contrasts you actually tested. Now, that is how to do that. Now, I want to walk you through another example right now. What if in a situation? How do we set up a contrast in a situation where we actually want to conduct analysis of variance, but you know what? We realize that we have there could be some potential variables that could have effect on the response. You remember when we were dealing with the multiple linear regression, where you know, initially you started with a simple linear regression where you're looking at the effects of a particular predictor on the response, and you decided to include some other predictors that could have effects on the response. Now, I'm going to show you now. We could conduct analysis of variance where, you know, I told you something the other time. When you want to conduct analysis of variance, the factor have to be categorical. You know that, right? You're only going to have a categorical predictor. You know that, right? But at times we could have situation whereby in analysis of variance, there could be a particular predictor that could also have effects on the response, and we actually need to incorporate that into the model, and that is what we call analysis of variance with covariates. Okay, now let me walk you through this example now. I wanted to see, look at this example right now. Basically, I want to look at the effect. What is the role played by the rank of a professor in the salaries? I'm going to say that again. I actually want to look at the effect of the rank of professors, okay, the professors' positions on the salary they got at the end of the day. Okay, and you know what? If I want to do that, it is not only rank that determine what professor gets. We could have some potential predictors like years in PhD. We could have there's a lot of other maybe discipline and so on like that. And you know what? Before we go into the analysis, we have what we call a priori hypothesis. Priori hypothesis, like a plan hypothesis. We basically want to see and want to test them. But let me tell you this. Let us first look at the rank of professors. You know, we have assistant professors, we have associate professors, and we have professors. How many levels in terms of rank? We got 3, right? Assistant professor, associate professor, and professors. Because we got 3 ranks, because we got 3 levels, how many contrasts are we likely going to have? It's going to be 2. Now, maybe the first contrast, look at what the first contrast is telling us. The first contrast actually want to compare. Now, let me first tell you this. Assistant professors are non-tenure positions. Associate professor and professors are tenured positions. What of in a situation where maybe before I go into the research, I actually want to test, is there significant difference in the salaries of a non-tenure track and a tenure track? When I say non-tenure track, I'm referring to assistant professor. But when I say tenure track, I'm basically referring to 2 levels. What are the levels that I'm referring to? I'm referring to associate professor and the professor. When you take a look at the first one here, I basically want to compare the salary of assistant professor with the other 2 levels of professors. Is there any significant difference in them? That's a contrast one. Now, the second contrast is basically going to be between the, within the tenure track position associate professor and professor, is there a significant difference in their salaries? Now, when you look at the two contrasts that I'm showing you now, these are the two contrasts we basically want to test. But you know what? This is the arrow code. Now, if I want to use analysis of variance, you know what I'm going to do, right? I'm basically want to look at the effect of rank on the salaries, right? But I told you now, we have other potential variables that needed to be included. Because of that, we're going to call those variables covariate. Now, variable like what? Sex, years in PhD, or years in service, and the discipline the professor belong, whether the professor is in CLA or the professor is in other department. You get what I mean? So take a look at that. Now, will you now run that? Oh my God. I wanted to say this now. You know what? This result, you know what this result is telling us? This result at this moment, it is not actually telling us now. It's only telling us the rank is significant. Look at that. If you look at the rank, look at the p-value associated with the rank. Now, let me tell you what are significant. The rank is significant. The years in PhD is significant. The years in service is significant. Discipline is significant. You can see that other covariates that we included are significant. And I told you the other time why you needed to incorporate covariates that have potential, that have effect on the response, because if you exclude them, okay, that will undermine the performance of your model. Now, do you know that here we have the fact that the rank is basically is significant? Okay, you can see that, right? And of course, that actually justifies the contrast that we want to test. We know the rank is significant now, but in the contrast, we basically want to see, is there any significant difference between the salary of a non-tenured track and a tenured track? And is there any significant difference between the salary of associate professor and the professor? Now, let me tell you, how do you do that? Now, this is an explanation. You know, I've been assigning negative values and positive value. Of course, we apply 0 as a weight for group that we are not interested in. And we apply negative weight for those one in the baseline group. We apply positive for the one in the treatment group. When I'm talking about associate professor and professor, okay, if I'm comparing them, of course, the associate professor will be in the baseline group, while the professor will be in the treatment group. Okay, now, based on what we're doing now, I'm going to show you the weights. Now, take a look at this. You know, initially, this is another way to put the weight. Another way to put this weight is to write under the associate professor for contrast 1, I can write half, 1/2, 1/2, and the other one is -1. There's no problem. This is what I'm trying to say. Look at this now. If you look at the contrast 1, this is assistant professor, associate professor, and the professor. And if you look at, I can write -1, half, half. There's no problem. Provided they added up to 0, you can see the way I'm using now, change that to -2, 1, 1. It's still the same. Does that make sense? Okay, now, if you look at, this is a contrast 1. What contrast 1 is trying to tell you, is there any significant difference in the salaries of a non-tenured track and tenured track? The tenured track as associate professor and professor. And the second contrast is only comparing, is there any significant difference in the salary? Okay, go ahead. Exactly. Now, what we use as a baseline, you know, we know associate professor is not up to professor in terms of rank. So the one in the lower cadre will be referred to as a baseline. Does that make sense to everyone? Like if you look at the contrast one, when I was comparing associate professor with others, when I was comparing assistant professor with others, assistant professor is lower in cadre to to the one in the tenure track. Therefore, the assistant professor will be awarded a negative weight. And the one I'm awarding 0, the one I'm not interested in. Okay. Now, this is the coding in R. The contrast 1, -2, 1, 1. Contrast 2, 0, -1. Look at that. Then this is the coding. And at the end of the day, we basically want to see results. Now, come and see now. We have how many contrasts? Rank, contrast 1, rank, contrast 2. Now, look at the p-value associated with that. You can see the contrast 1, the p-value is less than 0.05, which means there is a statistical significant difference between the salaries of non-tenure track and the tenure track. Every professor actually want to get into the cadre of a tenure track because they knew that there's going to be a statistical significant difference in the salaries. Now, if you look at the second one, this contrast 2, that is now comparing, is there any, within the tenure track now, within the tenure track, we got 2 levels, right? Associate professor and the professor. Is there any statistical significant difference in their salary? And the answer is yes. Look at the p-value. Okay. Before I go into I'm going to give you another example. I told you the other time the way I learn. When my professor give me an example in class, I like also giving my own example. And that's why at times when you look at the book, I used to tell people the textbook we are using is static. That textbook we are using now does not actually include what happened today. New things happens in different days, right? And I'm going to give you an example from politics now. How contrast can actually be used in politics. Now, let's say, for instance, we want to compare the voting pattern of the United States legislators, okay? Maybe with respect to tobacco bill, okay? Tobacco bill, okay? Tobacco bill. And let me tell you this. You basically want to compare the percentage of time United States legislators actually vote in favor of tobacco bill in Congress. And you know what we want to do? We want to look at the region. According to the Census Bureau, okay, the 4 region, we'll talk about the Midwest. Let me do this. Midwest, okay, West, South, Northeast. Now, legislators in the Congress, they basically come from this region. And you know what? Maybe because we have 1, 2, 3, 4, we got 4 levels, we're basically going to have 3 contrasts. Now, let me give you contrast 1. Maybe contrast 1, we have a belief, or we actually believe that maybe legislator from the South, maybe they voted more frequently than the legislators from the other region in the United States for tobacco bill. Okay, if you want to do that, this is basically going to be 1. Others, they're basically going to be 1/3, 1/3, 1/3. You see that? Here, you can decide, let me also tell you this. I can decide to put a -1 on and put a positive on this, or I can decide to say 1 and put a negative on the other one. Take a look at this. Okay. Now, but if you basically you want to compare South, if you're taking the South as a base level, and I talked about baseline the other time, you're going to say, okay, this is -1, and this is basically going to be that. This is contrast 1. Then in contrast 2, and we want to compare, is there a significant difference between legislator from the Midwest and West. Okay, the Midwest and West minus this guy, then 0, 0. And another contrast, I may want to compare between South and the Northeast. Maybe probably -1 and 1, then 0, 0. So what am I trying to do here? This is a planned contrast where I basically have 3 hypotheses to test. I want to see whether the legislators from the South, whether they voted more, okay, for tobacco bill in the House than the other legislator from the other region in the United States. Okay, if you look at the second contrast right here, I'm only comparing the Midwest and the West. And that's why you got the South and the North is 0, 0 because I'm not interested in them. And if you look at the last one, I'm only comparing the South and the Northeast. Okay, now this is another example for that. Okay, so I will advise that you also give your own example, because that is the way I understand. You know, when professor give me example, then I'm also going to cite my example. We are able to cite your example, then you really understand the concept. Okay, so the interpretation of what we just did is this. I said on ANOVA review that there was a significant effect of professor rank on their salaries. This is the first one that I did. Before we constructed the contrast, I was referring to when I was looking at the effect of rank. Okay, now when I also put into consideration contrast, you can see that the 2 contrasts tested, they're actually significant. You see that? So I said, while controlling for their sex and the numbers of years since they completed their PhD, okay, the numbers of years of service and the academic discipline they work in, and further investigation of the impact of professors' rank on their salaries using planned contrast. We call it planned contrast, or we call it planned comparison. Okay, it is different from the multiple comparison that we did the other time. I mean the Fisher, the Bonferroni, and the Turkey. Okay, so the impact of professor rank on their salary using a planned contrast revealed that being faculty associate or full professor. So being associate or full professor, it means the professors in the tenure rank, okay, was associated with a significant increase in salary compared to being an assistant professor. And that is the reason why majority of the assistant professor want to get absorbed into the tenure cadre, because of the fact that there's a significant difference in the salary. Okay, now, and I said, and that one being faculty, that is being a full professor instead of an associate professor, was also associated with a further increase. What we're trying to say, you could be in the tenure track, okay, and you're not the only, we have more than one cadre in tenure track. You have the associate professor and the professor. Then we also tested, we realized there is a statistical significant difference in the salary. Okay, so that is that. So that is all what I have for you today. Is there anyone who want to ask question or who need clarification? Like I said, do not hide your feelings. You pay for the service and you deserve to be served better. Okay, go ahead. Oh, okay. If I hear you clearly, you're asking about the coverage for the midterm 2, the chapters, right? You know, the midterm 1 is 01, chapter 012, then the midterm 2 is going to be chapter 3, 4, 5, and 6. Okay. You want to ask a question? Okay, whether I should recommend some resources where you can get data set for the project, right? Okay, now this is what thank you for reminding me that because I started grading practical 2 and I saw some data set that are coming in. What I'm going to do today, I'm going to share some link about, but it's going to be an online link, like where you can get data set. So watch out for that today, okay? I'll share that. Yeah, is there any other one? Any other person want to ask question? Oh,
Yeah,
okay, go ahead. Go ahead.
Yeah, so actually our group are collecting data and but I think our sample size right now is quite small. So may I know, is there any requirement for the sample size?
Oh, that's a very good question. Somebody online is asking about the sample size requirement. I understand the fact that we are in the middle of pandemic. How many sample size are you able to get right now? How many? What is the size?
Right now we got 16.
Okay, you got
But I think,
16, right?
yeah.
I'm gonna say, as far as I'm concerned, there's no problem. If it is only 16 you can get, then it means your analysis. What I basically want to test, I don't have a sample size requirement, but you know what I want to test on this project? I basically want to see how you are able to demonstrate practically the knowledge, the statistical knowledge you acquired in class. So whatever your conclusion is basically going to be on your sample size. Somebody who used 1,000 data set is going to conclude, going to say, okay, based on 1,000 data set. Somebody who used 16 sample size, the conclusion is going to be based on what? 16. Does that make sense to you right now?
Yeah.
There's no special sample size requirement.
Okay. And actually, like a few minutes ago, I just sent you an email about it.
Yeah, you
So,
can. Yeah, okay.
okay. And also in the email, I asked you if you can share our server link to our classmates to get a bigger sample size.
Yeah, you can. Are you the data set? Are you conducting survey, or you are? How are you getting your data set? How are you getting it? Can you tell me?
Sorry, what?
How are you getting your data set? Did you conduct a survey, or is something you get it
Yes.
online?
Is it only 2 question survey?
Oh, total survey, right?
Yeah, it's a survey.
Yeah, I understand. If it is only 16, you're able to get. I'm fine.
Okay.
Yeah,
Thank you.
you're welcome. Okay, so make sure you stay safe and have a very beautiful day. I'm gonna meet you on Friday.